Hi everyone, welcome to Math with Mr. Todd. I'm excited to bring you a brand new topic today. So you guys have done so great with graphing the last 2 weeks. We've been looking at tally charts, making graphs, reading graphs, and then we talked a little bit about data collection. So today we're moving into a brand new topic, which is fractions. And so fractions look like this. There's a top number and a bottom number, and they're split by a straight line right between them. So fractions, the definition of a fraction is it's part of a whole. So a fraction is part of one whole object. So there's two really important terms that we need to know and that we need to remember when we're talking about a fraction. And those two terms are what the two numbers in a fraction are. So the top number of a fraction is called the numerator. And the numerator is how many equal parts we have. Okay? And then the bottom number is called a denominator. And so the bottom number is a denominator, the top number is the numerator, and the denominator is how many equal parts are in total. So do you hear something, a word in both of these definitions that's the same? Right, so if you said equal, then you're exactly right. And that's the most important part about fractions, is that it's equal parts. Equal. So I have a little example here. So this would be the whole circle, okay? And I have how many equal parts in total? There are 2 equal parts in total. That's how we got that denominator. And then how many parts do I have, or how many parts are shaded in? 1. So this fraction is 1/2 because there are 2 total equal parts, 1, 2, and then 1 of those equal parts are shaded. So if I was thinking about this circle like a pizza, I would say, first off, man, if you were going to eat this whole side of the pizza, very impressive. First off, I would say there are 2 parts to my pizza, okay, 2 equal parts. That's how many I have in total, 2 parts. And then I have 1 part of that pizza. But, coming back to our definition of a fraction, part of a whole, the whole pizza is the circle, and I have this 1 part over here. So, just reviewing real quick on our terms, and then we're going to dive into making fractions and looking at different examples. 2 important terms, numerator and denominator. Numerator is the top number. How many equal parts do I have? And then denominator is the bottom number. How many equal parts are in total? Or how many equal parts has the shape been partitioned into? So partitioned is another important word that we want to remember. And that's when you put this line down the middle to make it into 2 equal parts. You're partitioning. You're cutting the shape into 2 equal parts. So we're going to dive into making some fractions together, looking at different ways that we can make fractions, and I hope that you're listening super careful because your activities are going to be directly related to this lesson. All right, friends, we're going to look at making some fractions, and the first way we're going to make fractions is looking at pictures of the fraction, or of a picture, and then writing a fraction about that picture. So over here I have a picture of some stars in 2 different colors. Now, Mr. Todd is not a very good artist, and these are not some very good stars, but you get the picture. So, the first thing we want to think about are those 2 terms that we went over, numerator and denominator. Numerator, how many do we have? Denominator, how many are in total? So if I said, let's write a fraction of how many of these stars are red, I would say there are 1, 2, 3, 4 stars in total. So that's the denominator. How many do we have in all? Okay, and then I'm looking at the numerator. How many are red was the question. How many stars are red? So 1, 2, 3 stars are red. Okay, so I'm going to say 3/4 of the stars are red. Okay, a little bit of a different picture this time. Same concept of the picture. We're going to make a fraction. This time I still want to know what fraction of the stars are red. So the denominator is staying the same because there are still only 4 stars in total. But this time, my numerator is going to change because the number of red stars changed. How many stars are red in this picture now? Right, 1. So this picture shows that 1/4 of the stars are red. Okay, last one practicing like this. There are a new number of stars, so that means that our denominator is going to change this time. The question still stands, what fraction of the stars are red? So this time the denominator is going to change because the last time there were only 4 stars in total. How many stars in total are there this time? Right, there are 6 stars in total, both red and black stars. Now, how many of those stars are red? Right, if you said 4, then you're exactly right. 4/6 of the stars are red. Now, here's something I want you to remember with fractions, friends. For us in 2nd grade, our numerator is always going to be smaller or equal to our denominator. In 2nd grade, let me say that again. In 2nd grade, our numerator is always going to be smaller or equal to our denominator. Let's look at an example of when our numerator and denominator would be equal. Friends, I wanted to look at one more picture with you before we move on to our next concept with fractions, and this would be when our numerator and our denominator are equal. And the question still is, what fraction of the stars are red? So, how many total stars do we have? Right, I have 6 total stars, so that's our denominator. But looking at this picture, how many are red? 6. So 6/6 of the stars are red. And that equals 1 whole. The whole picture is red. All the stars in the picture are red. All right, friends, our next concept with fractions that we're going to cover is talking about partitioning. And partitioning, remember, from when we went over vocabulary earlier, is when you break or divide a shape into equal parts. So I have a square here. I have a fraction over here, 1/4. And then I just wrote the word partition so that we can remember that we're going to partition this shape. So the first thing we're going to do whenever we partition a shape is we're going to look at the fraction and we're going to determine what the denominator is, because remember, the denominator is the number of total pieces we're going to have. So in this case, the denominator is 4. So I'm going to have to make this square, break it into 4 equal pieces. Now, equal is so important because what if I broke up, let's say this was a cake, and this is how I broke up the cake. And I said, all right, everybody, we have a party of 4 people, and one person's getting this piece, and one person's getting this piece, and one person's getting this piece, and then somebody's getting this really big piece. That wouldn't be too fair because the pieces are not equal, and that's not partitioning this shape into equal sections. So we're going to want to make sure that when we partition that our pieces are as equal as we can get them, because that's what makes a fraction, equal pieces. So for this shape, I'm going to partition it into 4 as equal as I can, remembering that, it's not going to be exactly perfect because I'm not using a ruler, but I'm going to try to get it as equal as I can. And I think that that's pretty close to being equal. So this is 1, 2, 3, 4 equal pieces because our denominator is 4. And there is 1 as our numerator. So I'm going to shade in 1 part of the square. So this picture now matches this fraction because there are 4 equal pieces and 1 is shaded in. All right, friends, I wanted to go the other way with you this time. So now I have a picture drawn, and I'm going to write the fraction to match the picture. So I have to think, first in my brain, how many equal pieces do I have? 1, 2, 3, 4. Remember, the total number of equal pieces is going on the bottom and is the denominator. And now I have to think, all right, how many pieces are shaded in? That would be how many pieces I have. 1, 2, 3. So this picture shows 3/4 because 1, 2, 3 of the 1, 2, 3, 4 pieces are shaded. All right, friends, last one, and then you get to try some on your own. So this is super important. Sometimes when we have a circle, it's hard to partition into equal pieces. So we're going to partition this into 4 equal pieces. And sometimes we think, oh, I can do it this way. But I want you to think about equal pieces. If I partition the shape like this, do I have equal pieces? This is not partitioning a circle into equal pieces because this top piece is bigger than this bottom piece and these pieces are bigger than the bottom. It's not equal. So you cannot partition a circle like this. The best way to partition a circle is by putting a cross or a plus sign in between or in the circle. So this is the best way to partition a circle because all the pieces are equal. So I have 4 equal pieces on my circle, and I'm going to shade in how many? Right, if you said I'm going to shade in 2 pieces, you're exactly right. 1 and 2. So there are 1, 2, 3, 4 total equal pieces. That's our denominator. And 1, 2 that are shaded in. That's our numerator. Friends, in our fraction assignment this week, it's fractions under the sea. Okay, I'm excited about that. And you are going to look at pictures of fish and write the fractions. And then you're going to have a bubble, and you're going to use the lines on the side of the screen, and you're going to drag them over and partition the shape, partition the circle into equal pieces, and then you're going to shade in using the pieces on the other side to match the fractions. Friends, you guys are doing an awesome job. I know that you're going to do great with fractions. If you have any questions with fractions, make sure to add a private comment on Google Classroom and I can help you. Or you can wait till Wednesday between 1 and 2 o'clock and I'll be glad to help you on my live office hours on Zoom. If you have any questions, remember, private comment on Google Classroom, Dojo message, or wait till Wednesday from 1 till 2 during our live office hours. Keep up the great work, everyone. I'm very proud of you. I know that you're going to get this. You've got it. You're so smart, and you are capable of greatness in anything if you just put your mind to it.